So let's discuss about Bernoulli's equation. So this one is one of the most important and useful method in finding the general solution of a first order nonlinear differential equation. Okay, so in here, okay, your Bernoulli's equation is basically dy all over dx plus p of x times y is equal to q of x times y raised to n, where your n should not be equal to 1. Okay, so this is Bernoulli's equation. So this equation looks actually similar to the first order linear differential equation standard form, because the standard form of a first order linear differential equation is dy all over dx plus p of x times y is equal to q of x. See, both of these equations are similar to each other. However, the difference is that your q of x has a variable of y. Unlike here, there is no variable of y. Okay, so that means in your Bernoulli's equation, there are two y's or two dependent variables, and each of them are basically in different functions of x, because you have your y as your p of x and you have y raised to n as your q of x. Basically, okay, let's just say you have a standard form of a Bernoulli's equation, which is this one, and you're curious or confused rather of which one is your p of x and which one is your q of x. Basically, if you have a variable of y that exists as a y only and it is partnered with a function of x, then that function of x would be your p of x. However, if the variable itself, which is y, has an exponent which is not equal to 1, and it is partnered with a function of x, then that function of x would be no other than q of x. Okay? So I'm going to discuss further to our given example. Okay, so there are two methods on how would you find your Bernoulli's equation. I do not know if there would be like one more solution or method for that or other techniques, but either way I'm going to discuss both of them. So the first thing is the common one, which is the integrating factor method of a Bernoulli's equation. So there are two formulas you need to know. First is the getting the integrating factor in a given Bernoulli equation. So you have u is equal to e raised to the integral of quantity 1 minus n times p of x. Your n here is basically the exponent of your y, okay, which is partnered with your q of x. Okay, so that's how you find your integrating factor. Now, after you find your integrating factor, you are going to use this um, formula to find the general solution. And remember, your n is basically the exponent of the y that is partnered with your q of x. Okay, so that's it. Now, for your second method is you're going to convert Bernoulli's equation into first order linear differential equation. So we have this one as your Bernoulli equation, Bernoulli's equation, I mean. Then it's transformed into a first order linear differential equation. And as you can see, the dependent variables is your u. So how is this possible? It's possible because when it comes to conversion, we are going to apply u substitution. Your u will be equal to y raised to 1 minus n. And once again, your n is basically the exponent of your y that is partnered with your q of x. Okay? So, after you have convert Bernoulli's equation to first order linear differential equation, now you're going to apply the integrating factor method of it. Okay? Integrating factor method of first order linear differential equation. So if you want to at least have more idea on how would you how would you solve a given first order linear differential equation by integrating factor method, I suggest you should watch the two videos that I made which is a practice video about first order linear differential equation. So I suggest you should watch those. Don't worry, I'm going to link it into my description of this video. Okay? But don't worry, I'm going to explain it while I am solving because I'm going to apply these two methods in one example. So, speaking of example, let's try to apply it here. So we have dy all over dx. Wait, let me fix my handwriting for a moment. So we have dy all over dx plus 3 all over x times y, 3 all over x times y is equal to, wait, there you go, 3x squared times y raised to 4. Okay, that's it. Now, this one is obviously in Bernoulli's equation because not only that the function of x here has your y, but on the right side, we have another function of x that has also y, but different exponents. And that exponent is not equal to 1. So, let's first apply integrating factor method. Okay. So, let's start with this one. Okay. So before anything else, we need to locate which one is your P of X, your Q of X, and your letter N, your small n, I mean. So your P of X is basically this one. Because remember, if there is a function of X and it is partnered with Y, like literally Y, then that function of X is no other than your P of X, which is 3 all over X. Next is we have your Q of X. So for Q of X, okay, basically, if a function of X is partnered with a variable that has an exponent which is not equal to 1 and it is located at the other side of the equation, then that would be your Q of X. So since here, your 3x squared is your Q of X, therefore, your Q of X would be 3x squared. Okay, that's it. And lastly, your n. The main reason why I include n here so that you guys will not be confused. So basically, your n is the exponent of the y. So here we have 4. Therefore, your n is equal to 4. Now, let's apply integrating factor method of Bernoulli's equation. So the first formula, u is equal to e raised to the integral of quantity 1 minus n times p of x. There you go. Okay. So let's substitute. So you have u is equal to e raised to the integral of 1 minus your n, which is your 4, times your p of x, which is 3 all over x. Okay. So let's simplify further. You have e raised to negative 3 times 3 all over x. So multiply them together, you will have u is equal to e raised to the integral of negative 9 all over x. So let's get the integral of negative 9 over x. So we will have negative 9 times ln of x. Okay, so that will be your u. But we can still simplify it. So by applying the laws of logarithm, we can put the constant negative 9 to the exponent of your x. So we will have u is equal to e raised to ln of x raised to negative 9. And if ever you have a base of t and then you have a logarithmic function, okay, I meant to say natural, sorry, natural logarithmic function, all you need to do is to cancel the e, cancel the ln, and copy what's the inside of the natural logarithmic function. I repeat, if you have a base of t and you have the exponent of a natural logarithmic function, you're going to cancel out the e and cancel out the ln and copy what's inside. So therefore, in this format, your answer is A. Okay? Now, let's apply it here. So cancel e, cancel ln, you have the answer of x raised to negative 9. That would be your integrating factor. Now, if we have your integrating factor, we can now proceed to this formula, which is y raised to 1 minus n is equal to 1 all over u times the integral of quantity 1 minus n times q of x times u. Okay? So now let's substitute. So your n is actually 4. So once again, 1 minus 4 on the exponent of your y. Then 1 all over your u. Your u is x raised to negative 9. Okay? Times the integral of 1 minus 4 times your q of x. Your q of x is 3x squared. So we will have 3 times x squared. And your u, x raised to negative 9. So let's simplify further. We will have y raised to negative 3 is equal to this one, this term. I can actually bring this upward. Like, I can bring, I can basically make it into the numerator by changing the sign of the exponent. So by changing the sign of the exponent, we can have x raised to 9. There we go. So 1 minus 4 is negative 3 times 3x squared, and let's copy the rest of the terms. Now, we can simplify these terms here, okay, inside of the integral notation. So negative 3 times 3x squared, so we have negative 9x squared. So negative 9x squared times 9x raised to negative 9, so we have 9x raised to negative 7. So how come that I got this result? First, I multiply the coefficients. Negative 3 times 3, I have negative 9. Multiply the x here. Since both of them have the same base, which is x, all you need to do is to copy the base and add, sorry, uh, and add their exponent. So 2 plus negative 9, or 2 minus 9. So 2 minus 9 is negative 7. Okay, 987. There you go. So what we're going to do now is we will integrate this one. Okay. So if you're going to get the integral for this one, we will have y raised to negative 3 is equal to x raised to 9. Okay. Times quantity. For this one, we will have negative 9 times 1 all over negative 7 plus 1 times x raised to negative 7 plus 1 and plus c. There you go. So we have y raised to negative 3 is equal to x raised to 9 times negative 9 times negative 1 all over negative 7 plus 1 is negative 6. So times x raised to negative 6 plus c. Okay. So in here, we will have, what do you call this one? X raised to 9 times, multiply negative 9 and uh, what do you call this one? And 1 all over negative 6 times x raised to negative 6. The answer here is positive. Wait. There you go. So again, multiply these two terms. We will have positive 3 halves times x raised to negative 6 plus c. Okay. So for me, you can, what do you call this one? You can leave this as your final answer. Or you can still simplify this one. You can distribute x raised to 9 to this expression. So we will have y raised to negative 3 times 3 halves times x raised to 3. Because multiply x raised to 9 and x raised to negative 6, the result would be x raised to 3 plus c times x raised to 9. So this is also considerable. Okay? Or you can factor out this expression by x cubed, since both of these terms are divisible by x cubed. So we will have x cubed times quantity 3 halves plus c times x raised to 6. There you go. So you can have this as your final answer. Or we can still simplify it even more. Remember that we have a negative exponent here. So we can actually bring it down to make it positive. So we have 1 all over y cubed is equal to x cubed times quantity 3 halves plus cx raised to 6. Okay. So I'm going to cross multiply, multiply the denominator to this side of the equation. So we will have 1 is equal to x cubed times y cubed times quantity 3 halves plus cx raised to 6. So that will be now my final general solution for this given problem. So that's basically it, applying first method, which is integrating factor method of Bernoulli's equation. Now, let's go to the second method. Okay, so I just draw a border here so that we can occupy the spaces here. Okay, so let's copy this one first for a moment. So what we're going to do is we're going to convert Bernoulli's equation into a first order linear differential equation. So first, we're going to apply u substitution. Let u be y raised to 1 minus n. And remember, your n is the exponent of your y here, which is your 4. So we have 1 minus 4. So you have u is equal to y, wait, u is equal to y raised to 1 minus 4. Yeah, basically. So 1 minus 4 is negative 3. So that is your u. Now, after that, we're going to get the derivative of this equation on both sides. So we will have du all over dx is equal to negative 3y raised to negative 4 times dy all over dx. Now, what we're going to do after we get the derivative on both sides, what we're going to do is we're going to divide both sides by negative 3 times y raised to negative 4. So we have negative 1/3 1 all over 3 times y raised to negative 4 times du all over dx is equal to dy all over dx. Okay, and we can still simplify this one because as you can see, your y here has a negative exponent. So we can bring it up to make it as a term on the numerator. So we have negative y raised to 4 all over 3. That's it. So what's next? Now, what we're going to do is we will substitute the given for dy all over dx here in this given equation. So we have negative y raised to 4 all over 3 times du all over dx plus 3 all over x times y is equal to 3x squared, right? Is equal to 3x squared times y raised to 4. So after that, we will divide both sides by negative y raised to 4 all over 3. So dividing the first term, which is this one, by negative y raised to 4 all over 3, we will have du all over dx. Next, dividing the second term, 3y all over x by negative y raised to 4 all over 3. Okay, I'm not sure. Let me try to divide it. So 3y all over x all over negative y raised to 4 all over 3. So we can reciprocate this one. So we will have 3y all over x times negative 3 all over y raised to 4. So in here, we have y's on the numerator and y on the denominator. So we can cancel out the y here in this numerator, and the y here on the denominator will be subtracted, the y on the denominator, the exponent will be reduced by 1. So we will have 3. So we have y cubed. So as a result, we will have 3 all over x times negative 3 all over y cubed. So we will have negative 9 all over x y raised to 3. So that's it. So we have negative 9 all over x times y raised to 3 or y cubed. Okay, then next, we will now divide the term on the right side by negative y raised to 4 all over 3. So in here, 3x squared y raised to 4. Wait. There you go. So if you're going to divide it, it's the same way on how I divide the second term. So I will reciprocate the denominator. So we will have 3x squared times raised to 4 times negative 3 all over y raised to 4. So I'll cancel y raised to 4 on the left and on the denominator because both of them are the same. So we can cancel them out. So we will have 3x squared times negative 3. So we have negative 9x squared as a result. So we have negative 9x squared. So we're not done yet, okay? Because as you can see, um, your u is equal to y raised to negative 3. So we can have your u here. It's possible. First, I will decompose this fraction into two factors of the product of denominator. Basically, I'll separate these variables. So I will have du all over dx minus 9 all over x times 1 all over y cubed is equal to negative 9x cubed. Okay? And remember, if you like to bring up the term upward or on the numerator, you're going to change the exponent into different sign. So since this is positive, so we will have du all over dx minus 9 all over x times y raised to negative 3. That's it. And again, your u is equal to y is equal to negative 3. So we will change this one into u. So here we go. We have now your first order linear differential equation. Okay. So after you convert this one into a first order linear differential equation, it's our turn now to apply integrating factor method of first order linear differential equation. So before that, we need to locate what is our p of x and our q of x. Remember, for a given first order linear differential equation, your p of x is located beside with the dependent variable. So since your u is your dependent variable and we have a function of x which is negative 9 over x, it is partnered with your u variable. Therefore, your p of x is negative 9 all over x. Again, since your u is a dependent variable, and then there's a given function of x that is partnered with a u variable, then that function of x right here, this is your p of x. Okay, that's how you find your p of x. And if you still don't get how I got p of x, I recommend you to watch these two practice videos about first order linear differential equations, integrating factor method. Okay, the next, your q of x is basically on the other side of the equation and act as a function of x only, and there's no other variable but as a function of x. So since here on the other side, we have a function of x, which is negative 9x squared to be specific. So therefore, this on the right side is your q of x, which is negative 9x squared. Now, what we can do is we will now use these two formulas. So what are these two formulas? First is to find the integrating factor. So what is the formula to find the integrating factor? The formula to find the integrating factor in a first order linear differential equation is u is equal to e raised to the integral of p of x. Okay, that is your integrating factor. Then after you find your integrating factor, then you're going to use this formula, which is u times y times the integral of u times q of x. Okay, but there's some changes that what we're going to do, right? We use your u to find your integrating factor, right? However, in this working equation, we use u as our dependent variable for a given first order linear differential equation. So in other words, we need to change this letter to avoid confusion. So I'm going to change from u to letter v. So v is equal to e raised to the integral of p of x. Okay, so there you have it. We have your p. Next, we have your y here, right? We have your y in this formula. And as you can see, your y is a usual representation for dependent variable. And as you can see, in this working equation, your u is your dependent variable. Therefore, we're going to change your y to u. Okay? So that's it. So this is your dependent variable because you use u here in this working equation as your dependent variable. Okay? You guys get what I mean? You guys get what I mean here? Okay? So I just changed the letters. Okay? And because it is based on the given differential equation here. Okay? And to avoid confusion and complications. Okay? So let's start first with this one. With your integrating factor. So let's find it. So we will have b is equal to e raised to the integral of p of x, which is 9 all over x. Okay. So the integral of negative 9 all over x is negative 9 ln of x. So that's it. Okay. But we can still simplify this one. Transpose negative 9 as an exponent for our x here. So we will have e times ln of x raised to negative 9. And remember, if we have a base of e and the exponent of e is a logarithmic function, we will cancel e and we will cancel ln. And hence we have b as x raised to negative 9. So this is now your integrating factor. Now we can now find your general solution. So let's substitute. So you have b as your x raised to negative 9 times your u is equal to x raised to negative 9 times your q of x. Your q of x is your negative 9x. So negative 9x. There you go. So now let's simplify. If you're going to multiply this one, we will have the integral of negative 9x raised to negative 7. Okay. So after that, let's integrate this negative 9x raised to negative 7. So you have negative x raised to negative 9 times u is equal to negative 9 times 1 all over negative 7 plus 1 times x raised to negative 7 plus 1 plus c. So you have x raised to negative 9 times u is equal to negative 9 times 1 all over negative 6 times x raised to negative 6 plus c. Okay, so multiply negative 9 and this term together. So you will have positive 3 halves times x raised to negative 6 plus c. And we're not done yet. I know it seems like we're done, but remember that your u is equal to y raised to negative 3. Okay? So therefore, we will substitute this one back. So you have u is equal to y raised to negative 3. That's it. Okay? So in this case, we can now stop right here. So this is now your general solution. Okay? Or we can still simplify this one. We can divide both sides, okay, both sides of the equation. Let me rewrite this for a moment. By x raised to 9 times y raised to negative 3. Okay, so we will have 1 is equal to, uh, wait, let me write it here. 1 is equal to 3 halves x raised to negative 6 plus c all over x raised to 9 times y raised to negative 3. So let's divide each of these terms by the denominator itself. So we will have um, 1 is equal to 3 halves x raised to negative 6. This is supposed to be 6, right? Yeah, this is 6, by the way. Okay. All over x raised to 9 times y raised to negative 3 plus c all over x raised to 9 times y raised to negative. So that's it. Okay, let me remove this one. And this is your c. Okay. So if you're going to divide them, you can apply what I did earlier, the one I did, like if you have at least one of the fractions on the side of the fraction, right, you're going to reciprocate. Try to do that one, okay? Because right now I'm going to be straightforward. So in here, if you're going to divide this one, the result would be 3 halves. Okay, wait. Uh, the result would be 3x raised to um, positive 3 all over 2 times y raised to negative 3. Okay? So, you know what? I'm just gonna teach you anyways. So, we have 3 times x raised to negative 6, right? All over 2, all over x raised to 9 times y raised to negative 3. So, let's reciprocate this one. So, we will have this one, 3 times x raised to negative 6 all over 2 times 1 all over x raised to 9 times y raised to negative 3. So this one, if you're going to multiply them together, we will have 3x raised to negative 6 all over 2 times y raised, 2 times x raised to 9 times y raised to negative 3. And if you're going to recall your laws of exponent, if you have two the same base, one from numerator and one from the denominator, and they have their own exponents, so we will have 3 times x raised to negative 6 minus 9. Okay. Wait, sorry. Wait, forgive me. Yeah, actually, I'm correct. You sure? Minus 9? Wait. For a moment. Wait. Forgive me. Right, we have negative 9. I forgot to put negative 9 here. Forgive me, guys. It's negative 9, negative 9, negative 9, and negative 9. Forgive me. Okay, I forgot to put the negative sign. Okay, sorry. Okay, so we have, yeah, negative 9, negative 9. Okay, so in that case, if we have negative 9 on your denominator and we have negative 6 on your numerator, we will have 3x raised to negative 6 minus negative 9. Okay, and since both of them are negative, so this would be positive 9. Okay, all over 2 times y raised to negative 3. So add these two together, negative 6 plus 9, you will have positive 3. So you have 3x raised to 3. There you go. So you have this one. Okay. So that's how you do it. Okay. Then copy the other term. So we have c all over x raised to negative 9 times y raised to negative 3. Okay. So we can bring up all of the terms at the numerator, especially to those who have negative signs. We can do that. Okay. So what we're going to do is we're going to bring this term. Wait. We're going to bring these terms, okay, to the numerator by changing the exponent. So we will have 3x cubed, 3 halves times x cubed times y cubed plus x raised, c times x raised to 9 times y cubed. Okay, that's it. So yes, we can leave this as our final answer, but we can still actually simplify this one. Okay, we can still do that. All right. So in here, we can factor out x cubed and y cubed on this expression. So we will have 1 is equal to 3 halves times x cubed times y cubed times quantity 3 halves plus c times x cubed. So we can leave this as our, wait, I'm wrong. Sorry, forgive me. What I did here is I just factor out x cubed, y cubed. Okay, so yeah, we have this one already. So after I factor out x cubed and y cubed in this expression, I have this one as your final answer. X cubed times Y cubed times quantity, 3 half plus C times X cubed. So I'm going to stop right here. And this is now my general solution. So let's take a look if they are the same. So as you can see, the last part, oh, wait a minute. This is supposed to be 6. Forgive me. Okay, forgive me guys. This is supposed to be 6. Because if you factor out x cubed and y cubed, this 9 will be reduced to 3. So 9 minus 3 is 6. Forgive me. So again, that's it. We're already done. So let's take a look if they're the same. So the last part and this one, they are the same. Okay. So there you go. Okay, it's up to you on which method would you like to pick. For me, I highly recommend this one, the first method. Okay, the first method. So forgive me if I speak quickly because I'm actually in a hurry. But yeah, this is how you solve Bernoulli's equation. Thank you.